Hello everyone, my name is AP and I'm the instructor of this particular training. So we are starting with Cisco SD-WAN training. So first of all, we will go by the introduction of what is Cisco SD-WAN and what are the audience of this course and who should take this particular course. So let me start by introducing myself first. So my name is AP and I'm having more than 6 years of IT experience working on various technologies, covering networking, Cisco and multiple vendors like Huawei, Juniper, and the Nokia as well. And I'm also having an experience on the security firewalls, right? And I'm also DDI solution certified, basically in Infoblox. Currently, I'm working as a senior escalation engineer in the Infoblox. Okay, and right now we are taking this particular training Cisco SD-WAN, and yeah, so that's a brief introduction about myself. So let me start by introducing what is Cisco SD-WAN and who should take this particular course. Okay, so
ऐसे लग रही है आवाज है
I hope my voice is clear to you with it. Is it?
Yeah, you can go ahead. I was talking with someone else on another voice, so you can go ahead. It's okay.
Okay, okay. You can mute yourself. Thank you. Okay, so basically, the introducing Cisco Viptela SD-WAN. So initially, it was known as Cisco Viptela SD-WAN. Currently, with the new software version and the new advancement, this technology is known as Cisco Catalyst SD-WAN. Okay, so starting from who should take this training, right? Who is the audience of this particular training? So basically, whoever in the networking profession, right, working as a networking professional can take this training. And the basic, who has understanding of TCP/IP model with the basic understanding as a system administrator or the field engineers, and who already having a multiple advancement in their career and who want to gain a particular technology to learn a new technology, so they can take this course, right? A technical support engineer who are already familiar with the networking technologies, so they can take this course. And whoever already have a lot of skills in their career and they want to upgrade their skills and want to learn Cisco SD-WAN, definitely they can take this particular course. Yeah, so starting from why do we need SD-WAN? First of all, what SD-WAN is all about. So as you can see from the full SD-WAN name itself, it's wide area network. So basically connecting remote sites, connecting everyone through the internet, wide area network, right? And something called SD is a software defined. So basically everything is going through software defined. So everything should be automated, right? So basically the SD-WAN terms. So just a high level overview of SD-WAN terminology. So starting from why we have introduced the SD-WAN. We have already a traditional SD-WAN going, existing traditional WAN, and why we have introduced the SD-WAN. So first of all, we need to understand why we need this technology and what are the challenges in already going on traditional WAN. So first of all, you're already aware about that a lot of organization and a lot of businesses are using a software application which are hosted in the cloud, mainly in the Amazon, right, which is known as AWS, Google Cloud Platform, and Microsoft Azure. So most of the business organization are going toward software as a services. So they are hosting their application and they are making already established software application in the cloud. So they are making use of it. So with the adoption of software as a services, infrastructure as a services, most of the applications are now hosted in the cloud, right? So now, for example, a particular organization has its own business application, which is organization specific application. Those are hosted in the data center. Now, the challenges in the traditional WAN is that this particular software as a services application, for example, Office 365, Salesforce, and so. These applications are hosted in the cloud. Now, that requires the internet connection. So, for example, a user sitting in a particular branch or a remote site that want to connect to that particular application, so that requires the internet connection. So mostly, so in the traditional WAN, how this particular traffic is routed towards that particular application, software application on the cloud. So basically, users send this particular traffic to the data center, and from there, data center will send those particular traffic over the internet line to the cloud. So that includes latency accessing that particular application, because your traffic is not going to the internet directly. Rather, it is going to the DC and then going to the internet and to the cloud. So that introduced the latency. You can see that particular challenge here as well, higher latency. Now, for example, your traffic is going through your remote edge and then go to DC and then go to cloud. So that also consume a lot of bandwidth of the line, right? So we have to optimize the bandwidth as well, and we have to, and that is very costly, and we have to get a lot of bandwidth from the service provider. So that also that is another challenge with the traditional WAN. That's a cost. And the availability. For example, the DC, where your traffic is going through the internet. Now, first of all, you must have that particular question, that why we are routing this traffic from DC to the cloud. So that's a big question, right? So you need to understand that why we are routing the traffic to the DC and then to the cloud. So basically, there are a lot of firewalls and the security applications through which your remote sites traffic is going through. So you need your traffic to be inspected on the data center. So placing of multiple firewalls on all the remote sites is actually very costly to every business organization. So mostly the common deployment is that we are deploying the firewalls and all the security appliances on the data center itself. So the traffic from the remote site is coming to the DC and then going to the cloud. So now you need to understand that it's a single point of failure. For example, your data center fails, it's a availability challenge as well. And again, one more thing, in the traditional WAN, you have to SSH, you have to take the access of each and every device individually, and you will take the you will do a configuration, you will troubleshoot there as well. So basically, you have to log in into a particular device one by one, and you have to troubleshoot, you have to configure. So that's a completely decentralized management. So we don't have any centralized point from where we can configure every devices. And yeah, that's a challenge. So these are four main challenges with the traditional SD-WAN, traditional WAN only. Okay, so business need to think about the different model that adapt to these particular changes and the challenges in the existing WAN. So the changes means because most of the organization are adopting the software as a services SaaS application, right? So we need to have a particular design or a new technology that can address these particular challenges. So SD-WAN has been introduced. Now you need to understand that this is SD-WAN. So basically, this is mainly focusing on the WAN side, right? There is another SDN, which is particularly focusing on the LAN side, right? So that's we call the campus software defined networking. So that's simple SD-WAN, and the controller for it are different in the Cisco. So our main focus is SD-WAN here. Now, you need to understand that SD-WAN comes into two flavor. One is Cisco Meraki and one is Viptela SD-WAN. Meraki solution is for small and medium enterprise solution, and SD-WAN is for organization which is having like a lot of appliances and a lot of devices, right? So it's mainly focusing on the big organization, right? Now, we have understand that why we need SD-WAN. We have already understand that why we need SD-WAN and what are the challenges with the traditional WAN network. Now we need to understand that what is SD-WAN actually, and what are the benefits we can get with SD-WAN, and is it really solving the challenges we are facing in the traditional SD-WAN? Now, first of all, you need to understand that Cisco SD-WAN is utilizing the underlying transport which is already available. For example, we have a dedicated internet line, right? Whether it is with one service provider, whether it is with two service provider or any other 4G or 5G emerging technologies. Now, First of all, you need to understand that there are additional components which is introduced in the SD-WAN. Now, each of the component has its specific purpose. Now, starting from the controller, we can see here we have 4 controllers with us. So vSmart, vEdge, sorry, this is not a controller, vSmart, vBond, and the vManage. So Cisco has introduced 3 SD-WAN controller in the SD-WAN, so which is vBond, vManage, and vSmart, which has its specific purpose. So we have a challenge of centralized management. So we have to log in each and every device, and we have to configure and troubleshoot from there. And also we do not have a big picture that how our topology is with our organization on the SD-WAN. So this is the management, this particular controller, vManage, is a management plane of the SD-WAN. Now, SD-WAN has separate every plane, management plane, control plane, and the data plane completely. This is a complete separation of all the planes, right? Now, the second controller is the vSmart, which is control plane of the SD-WAN. Now, let me introduce by the plane, what does it mean? So management plane is basically responsible for configuration, right? So whatever we configure on the device, that's we call is a management plane. Now the control plane, the route exchange between 2 device routers and the controller. So that's a route exchange. We call that as a control plane. So the control plane is completely separated, and that job is taken care by the vSmart. So no route exchange is directly between 2 routers. With the actual route is going to the vSmart, and vSmart will push that particular route to the WAN edge. And what I mean by the WAN edge is basically a WAN edge router on a particular remote site, or it's a headquarter sites. Now coming to the vBond. vBond is nothing but the authenticator. For example, we have introduced a particular WAN edge on a particular remote site. We have to authenticate itself to all this controller, vSmart, vBond, and the vManage. So first of all, when a particular router is introduced on a remote site that needs to be authenticated, that job is done by the vBond. So basically, I will show you this practically right now in this particular webinar. What are these particular controller and what's the job of it? So you will see everything in the practically. Okay. Now another part is the data plane where our actual packet forwarding takes place. So that's a data plane, and it could be V edges or the C edges. Now you need to know that it's a virtual edges. It's come in 2 flavor, virtual and the physical router. So the physical router who has Cisco iOS XE operating system, this supports this particular SD-WAN functionality and the virtual edges. Now that you have understand that what are vManage, what is vSmart, and what is vAuthenticator or vBond, right? We'll move on to the how this particular thing works. Okay. Now you see these 7 steps, and we will see each and every steps practically right now in this webinar. So first of all, we need to deploy the controller. Okay. And each controller has its own functions. So first of all, we will deploy this controller. So now the big question is, where do we deploy this? So this controller consumes a lot of memory. So most of the organization tend to go for a cloud. So they deploy in the cloud. So now you can understand from here, this particular diagram, that it can be deployed in the cloud, AWS, Azure, or the GCP. Even if the business organization have its own private cloud, they can host this particular controller there, or you can host this particular controller on premise, and you have to buy a physical server, right? It should have a high number of system resources, and you can hypervise it. And from there, you can host this particular controller on premises. Okay. Now, the next thing you need to understand that how we need the onboard the WAN edge. So WAN edge means basically your router on the remote side, your router on the headquarter sites. How we are going to onboard this particular router that will talk to this particular controller and talk to other remote sites as well, and also the route exchange and the data packet forwarding. So basically, once we introduce this WAN edge router, okay, it has its own chassis number and the serial number. So we have to create a smart account on the Cisco website, right? From there, your vManage device can download the serial file of all these WAN edge. I will show you this practically as well. Okay, first of all, just understand the theory, so you will get a little highlight of how it works. Okay, and the next thing is that we have to authenticate that particular WAN edge, because anyone can introduce the router and just introduce or announce itself that I am a part of this particular SD-WAN fabric. So we have to authenticate that particular router with VBON. VBON will authenticate that particular router, and after the successful authentication, VBON controller, which is the authenticator, will provide the information of vManage and vSmart, IP address and the hostname of the vManage and the vSmart. Next thing, as we know that we need to understand that the connection between this controller and the VNet should be secure. So VNet will make a permanent connection to the vManage, okay, via each available transport. No, it will pick one of the available transport and will make the permanent connection. For example, VNet have two internet connection. One is, for example, via internet service provider Airtel, and another is internet service provider via Jio. Now, VNet will make a permanent connection, and it will pick a particular transport, any of two, okay, and will make a permanent connection to the vManage. Now from the vManage, it will download the configuration which is on the vManage via netconfig protocol. The next thing, it will make a secure connection with the vSmart controller, and from there on, it will download all the policies, routing information on all the security policies we have configured. So these are the high-level overview of how this SD-WAN works. Now the next thing, what are the benefits we are getting using of this SD-WAN? So the first thing, we can connect any location in a fast and a secure manner. Now the secure manner, what part of SD-WAN provides the security? So basically this controller, when making a connection with the VNage, so it making a DTLS channel automatically over a particular port 12346. Okay. Basically TLS and DTLS. TLS makes use of the TCP and the DTLS makes use of UDP. So they make this particular connection. So whatever the communication going through this control and the VNage will be completely secure. Okay. So now another thing is transport independent WAN. So we can make use of any transport, for example, internet, 4G, LTE. So whatever the underlying transport, whether it's an internet, we are using MPLS or the 4G or the 5G technologies while connecting. For the reachability, we can use any transport. So that's another benefit. Now the next thing is that abstracting the underlying WAN infrastructure away from the services. So basically, we are just making the underlying WAN, which is internet, MPLS, 4G, 5G, two internet service provider. So basically, we are just making use of it, and over on the top of it, we are running the services. Our VPN services going on, our communication through the remote site, communication to the headquarters, and the connection or accessing the application over that underlying WAN. So complete separation from that. And there is end-to-end security. For example, two remote edge sites wants to talk to each other, right? So basically, there is a TLS channel. There is an IPsec channel. So the protocol, encapsulation protocol, we can use GRE or the IPsec. So whenever particular VNage router is onboarded and another VNage is also onboarded, the IPsec channel creation is automatically, and it provides end-to-end security. We don't have to intervene and configure the IPsec channels or the site-to-site VPN between two remote sites. It will be automatically. So that task is also automatic. That's another advantage. So end-to-end security. And this is, again, we have already covered that, the centralized management, and we can also analytics. So basically we can troubleshoot and we can analyze all the traffic going on in our SD-WAN overlay fabric. And another thing, the REST API, we can make use of REST APIs here as well. So it's completely automatic. So automation, we have introduced the automation here as well. We will also cover this particular topic in the course. The next thing is that the application aware routing. So what do I mean that application aware routing? For example, each and every organization has a particular application going on through the internet, going through the data center, going through another remote site. So the application could be anything. It's a voice, it's a video, or the web browsing, it's a VoIP call. So each and every application has its own tolerance. So for example, if voice is dropped, it's dropped. we cannot recurve it, right? So it has a particular tolerance of the latency, right? The jitter. So we can configure our SD-WAN overlay fabric in such a way that, for example, we have a two internet service provider, and we will configure the tolerance of that particular application or the threshold of that particular application that it can only tolerate this much. If that particular internet line, for example, one internet line has a high latency, the traffic will be automatically routed to another internet line. So that's a completely application aware routing. And we can configure based on our desire and the organizational need. So that's a completely application aware routing. Now the big question is how the router will identify the application. So basically this all WAN edge router, vEdge and the Cisco IOS XE is embedded with all the application. It make use of NBAR network recognition of those applications. So basically more than 5,000 applications are already inbuilt in the router. So whenever it will look at the header of the packet and will understand that which application it is. So we will also see that how the applications are visible on the router itself. So whenever the packet going through the router, it will automatically detect that this particular traffic is of this particular application. Okay, so that's application aware routing. We have a dedicated session on this particular topic, application aware routing. And the main advantage, direct internet access. Now, if you remember in the last slide, I have explained that what our traffic is going through the data center and then go to the cloud. Now, the big question is why we have sent this traffic to the data center. I have also explained that we have a security stack available on the data center, and we want each and every traffic to be inspected, right? And that introduced a high latency. Now this particular feature, direct internet access, now we have a complete control on the router itself that can provide the security, right? It can go through the security edge stack itself. It can identify the application, we can block it, and we can allow, disallow everything, right? It can go through the, we can configure a lot of policies, centralized control and centralized data policies on the router itself. So that makes us possible that we don't have to route the traffic to the data center every time. We can route that particular traffic to the cloud directly from the router. So that will solve the problem of the latency. Okay. Now the training content, high level overview. So first of all, we'll start with setting up controller. Okay, just give me a moment. Thank you. So the content of the course is, first of all, we will explain how to set up this particular controller in the lab. Okay. The next thing is how to provision the WAN edge on the lab. Okay. In the SD-WAN overlay fabric, how we can provision the WAN edge, how we can whitelist and authenticate this particular WAN edge. We are going to cover this in detail. And the overlay management protocol. Now, this is something which is new to you guys who are not aware about the SD-WAN introduction. So basically, we have understand that we have a vSmart controller, which is nothing. If you have studied the BGP, it's there is a concept of route reflector. So whatever the router which is having a neighbor relationship with the route reflector, so it will give the route to the route reflector, and route reflector will give route to another neighbors. So basically, it's a relay. So overlay management protocol. So vSmart, whenever the WAN edge router is on board, it will advertise its connected, static, and the OSPF route. Based on the configuration, it will send those particular route exchange information via overlay management protocol to the vSmart. Now vSmart will send those particular route to the another remote sites based on the configuration. So it's an overlay management protocol which is responsible for route exchange, okay, and so on. Okay, feature and the CLI templates. So we have covered that we are configuring everything on a centralized manner. So we can create a template and we can reuse each and every time if you want to. For example, if there are identical configuration on the particular router, we can make use of the templates. And they are in two flavor. Feature template, basically we can configure, we don't have to remember the command. So this is one advantage that, for example, we have to remember the command. For example, to configure the IP address on the router on the interface, we have to go into configuration terminal. We have to type interface and then give the IP address and the subnet mask, and we will make no shutdown and will come out of it, right? So we have to remember each and every CLI. Now the feature, we just have a I will show you that how exactly it is. So feature, we don't have to remember the each and every command. We just know that this is the concept. We can simply enter the value of that particular feature, okay, and the CLI. And now from here, you need to understand that you have to remember the command and you have to manually type that on the vManage itself. So this is the template which can be reusable for each another device. So the device template, so basically all this feature and the CLI template can be embedded into the device, and the name suggests itself that this particular device template can be pushed on a particular device. So we will understand the difference between these templates as well, and something called TLOC extension. So this is nothing but, for example, we have one internet service provider, we have another internet service provider, and the VNCPH router has two internet connectivity directly, right? And for example, there are two VNCPH services. Let me explain this in such a way that, for example, there is a site, okay, and there are two routers in it, and each router has separate internet service provider. For example, okay, I will explain this graphically so you will understand that, because in theory you will not understand it completely. So visual diagram would be helpful in understanding the TLOC extension. But yeah, definitely we'll cover this in upcoming training. So we are going to understand the routing, how this connected and static routing work in the SDWAN overlay fabric, and the SDWAN routing, OSPF and BGP, how it works. Okay. Okay. The next thing we understand is traffic engineering. Okay. So how we can manipulate the traffic. Okay. How we can, there is a lot of stuff in the traffic engineering. We are going to cover that. Okay. And the dual transport. SDWAN topology, it could be full mesh, it could be partial mesh, it could be hub and spoke, right? And again, the same thing. Okay, application aware routing, we have discussed that. SDWAN service chaining, this is something new for you. Basically, for example, a remote edge sites. There are, for example, there are 4 remote sites and a 1 headquarter sites. And one of the remote site has, for example, security stack, and we want each and every traffic going through that particular security stack. We can make use of service route. So each and every traffic going through another remote sites can be pointing towards that particular service stack and going through that particular remote sites. So yeah, we will also cover this particular traffic practically and the theory as well. And something called John-based firewall. So now you understand that we have a traffic going through the data center and to the cloud. So that's introduce the latency. So on the router itself, we can configure the zone-based firewall, and we can allow and disallow the traffic going through that particular router. SD-WAN VPN segmentation. So the segmentation itself, we can separation of the traffic. For example, a particular branch has a particular user going through the VPN XYZ, and another group of user going through the VPN, for example, ABC. So basically, this is a separation of the traffic. So we call is a VPN. And if you're familiar with the concept, which is VRF, right? So we have a completely dedicated routing table for each and every customer. This is the same thing. We just call it as a VPN. This is a VRF. Okay. Now the next thing we are going to cover, this is main thing, network address translation, because we need direct internet connectivity. So definitely we need to understand that how net works in the SD-WAN overlay fabric. So we are going to cover the different flavors of the net in terms of, with regards to SD-WAN, how they can be configured. Now the policies, we need to understand the centralized control and the data policies. We are going to cover multiple labs on it, and we are going to cover this particular topic in much more detail. So basically, control means we are controlling the route. Control means we are basically controlling the control plane, the route exchange, and all those stuff. And the data policies, we are actually controlling the data packet after route exchange. And the centralized means this particular thing will be affect to all SD-WAN overlay fabric. Localized means this particular policy will be localized to that particular router only, and that affect to that particular router only. And the control and the data is the same thing, right? So control, basically we are controlling the route, controlling the control plane, route exchange, and data policies. Basically, we are controlling the data packet, actual data packet forwarding, and the direct internet access. We have discussed this multiple times. So this is the high level overview of the training content, and it would be, everything would be in much more detail practically. And now the training details. The basically this course is commencement date is a 4th of November. And the total course content would be 30 plus hour, and it could be extended up to 40 as well, or 35 hours as well, depend on how we are driving the class. Okay. And the duration of each class would be approximate 2 hours, and the class would be conducted on every weekend, Saturday and Sunday, 5 p.m. Indian Standard Time. And the training cost is 12K for students in India, and outside of the India, the cost is $200. Okay, thank you for your time, everyone. And if you have any question, please feel free to ask. Thank you.